there are several ways to write the formula of organic compounds, and it can be written using the molecular formula, right? Molecular formula, or it can be written using condensed, okay, the condensed method or the condensed way. And then the third one, it can be the structural. And then the fourth one can be the skeletal. There are a few more in writing the formula for organic compounds, such as the 3D or the structural in the style of Lewis. But the structural that we're going to use here will be straight lines only. Now, let's have an example. So let us say we have an ethane. Okay. The molecular formula for ethane is C2H6, and then the way you write this in condensed is you just distribute C and then the hydrogen. So you have 2 carbon atoms, okay, and then right there the hydrogen and then another hydrogen. So if we're going to count the number of carbons, we have 1 and then 2. Now how about the number of hydrogen atoms? So we just have to distribute it. So we have here 3, so that's 3, and then 3 here, total of 6. And there should be a line, okay, or a dash. The dash represents that they are bonded together. Or you may also see a condensed way of writing down an organic compound without the dash. It is just like this: CH3, CH3. So that is also a condensed way of writing a organic compound. Okay. Now how about the structure? So let's distribute the carbon and another carbon. Let's connect them together with the line. The line represents a bond, and then the 3 hydrogens on this side, 3 hydrogens also here and here, for a total of 6. So 1, 2, 3, 4, 5, and then 6, right? So for every carbon atom there are 3 hydrogen atoms. You can see it here as well as on this side. Now for skeletal, it's very simple. Since there are 2, we can represent it by just a dash or a line. Both ends of the line, okay, represents the presence of carbon atoms, okay, that has hydrogen in it. But we do not write the bondings, the hydrogen anymore or the carbon anymore, because this is already understood, right? So when we see a line, when it comes to writing down the organic compounds, when we see a line, it is understood that there are carbon atoms on both sides, okay? And on those end, meron siyang hydrogen bonds, right? Meron din siya lang, right? So let's have another one. Let's say methane. Methane is, the molecular formula for it is CH4, right? Now we cannot condense methane anymore, right? So we can just copy it, because this is the least number for the compound CH4. And what we can do is do on the structural formula or the structural way, which is like this. So since there are 4 hydrogen atoms, so H here, hydrogen here, and another one. Okay. Again, the lines here represents a bond, and since these 2 are both non-metal, let us recall our bonding or chemical bonding lesson. Okay, it is called a covalent bond. Okay. So we cannot do skeletal for methane because there's only 1 carbon. Okay. Now for propane, that's just another example. Right, let me write it down. The chemical formula for that is C3H8. Now, to write the condense, okay, you can do the condense here because it has more than 2 carbon. Okay, so have CH here, another CH, and then another CH. Right? So, if we count the number of carbon atoms, we have 1, 2, and then 3. Now, let us distribute the hydrogen. So, the hydrogen should be here is 3, here should be 2, and here should be 3. Now, why is it 3, 2, 3 and not 2, 3, 3, or the other way around? So, let us check and examine the structural way of writing propane. So, it should be like this. 1, 2, and 3. And then, the ends of this compound should have 3 hydrogen atoms. Okay, hydrogen atoms, another hydrogen, and then the center, the middle, will have 2. Right? So now, this can tell us, right, that it has 3 hydrogen atoms, okay, and this part has 2, and then this part has 3. Right? So, how about the skeletal? So, since there are 3, it can be represented like this. 1, 2. Right? So, that means there is a carbon here, there is a carbon here, and another one here. Okay? So, now, let's go to nomenclature or naming the hydrocarbon. For now, we are going to focus with alkanes. Okay, since we've started it with ethane, methane, and propane, so these are all examples of alkane, hydrocarbon alkane. Now, I would like you to take note of the following. When naming an alkane, okay, you have to determine the number of the longest chain, or the carbon, the number of carbon in the longest chain. So, for example, let's go back here. Okay, let me change the color of my pen. So, this, for ethane, we have 1, 2. Okay, we have 2 numbers of carbons, so that is the longest chain for this compound. Now, if the number of carbon in a chain is 2, you're going to use it. If it is 3, prop. If it's 4, bute. If it's 5, pent. If it's 6, hex. If it's 7, hep. 8, oct, and so on and so forth. 9 for non. Alright? Also, you have to consider this. Okay, it should end with A, N, E. Right? So, the first example that we have is this. Okay, let me write it down. This is our first example, ethane. Okay. Now, when you hear the word it tells you that the longest carbon, that the longest chain, or the number of carbon, okay, in this kind of compound, it tells us that there are 2. Now, how about the A and E? As agreed, we have to end it using this one, A and E. So, the chemical formula is C2H6. Let's write it down. C2H6. Now, how do you determine the number of hydrogen? So, we follow this formula. Okay, the formula tells us CnH2n plus 2. So, how did we get 6? It's like this. The carbon is 2. And for H, we have 2 times 2 plus 2. Right? So, that gives us C2. H2 times 2 is 4 plus 2 is 6. Right? So, that's how you determine the number of hydrogen. Okay, let's have another one. Now, let us have propane. Right. Now, by just looking at the word prop, okay, it will tell us that it has 3 carbon atoms, right? 3 carbon atoms. Now, the A and E tells us that it is a hydrocarbon alkane. Okay, it belongs to alkane. So 3C, if you're going to write the formula, it should be C3. How do you get the number of hydrogen? How will you know? So we just follow this formula. So that would be 2 times the number of carbon. This one is 3 plus 2. So we now have C3H. 2 times 3, 6 plus 2 is 8. Okay, so this is the molecular formula for propane. And if you want to write its condensed, just like the previous example, okay, so you may distribute it like this: CH, CH, and another CH. So distribute 3, 2, 3. So this is the condensed way of writing the formula of propane. So we can check it, right? See, it's CH3, CH2, CH3, right? CH3, CH2, CH3. Okay, and if you want to write it using the structural, you just have to go back here. So it's like this, right? It's like this. And if you want to write the skeletal, it should look like this. Pwede rin pababa if you like. So long na tatlo siya. 1, 2, and 3. Right? Okay. Now let's have another example. So let's say methane. Yung kanina. Okay? Let's have methane. So the meth will tell us that it has 1 carbon, and then the A and E tells us that it belongs to alkane, or a hydrocarbon alkane, right? So how do we write this with the molecular formula? So we have C, since it's only 1 carbon. How do we determine the number of hydrogen? So we just follow again the formula. So that would be 2, right, times 1 plus 2. You don't have to write 1 here as a subscript. Okay, that is not necessary. Okay, that is not necessary. Okay, the C, okay, understood na 1 yan kahit wala siyang subscript. Okay, so H, 2 times 1 is 2 plus 2, that gives us 4. So the molecular formula for this compound is CH4. Okay, and if you want to write the structural formula, okay, it's like this: 1, 2, 3, and then 4.